Okay, these are the solutions to the last two problems. Suppose that $700 is compounded continuously for 122 days, and the account balance has grown to 715. Calculate what the interest rate must have been. So we're going to use this formula for continuous compound interest is that the amount in your balance is the amount you started with times e to the r times t, where r is the interest rate. And in our case, we know some of these things. The account balance has become 715. The principal, what we started with, is 700. And the time is 122 days. And now all we got to do is rearrange and solve for r. We got to make sure the interest rate is going to be in the units of 1 per year, and then we'll have the answer. So to solve for this, I'm going to move the 700 to the other side. So this becomes 700. I take the log of both sides, ln of 715 over 700, and that is going to be r times 122 days. And therefore, r equals 1 over 122 days times the ln of 715 over 700. And if you did this, you would get the right answer, but the units are in 1 over days right now. So to fix the units, I'm going to multiply by 365 days in 1 year. And that will fix the units to be 1 over year. So the final answer, 365 over 122 times the ln of 715 over 700, and that's in the units of once per year. Let's do this one on the calculator. Bring that up. 365 divided by 122, that's the first number. And I gotta do 715 over 700. That's this 1 point number. I do the ln. I think I've lost the first number. Times? Okay, let's start over. Let's start over here. So start over. Okay. 715 over 700. Do the ln. Boom. That's the ln part. And then I multiply by 365. And then I divide by 122. And that is 0.0634. 0.0634 per year, also known as 6.34% per year. So the answer, the interest rate per year, 6.34%. Okay, and that matches the answer on the sheet. I again think this one was taken directly from the posted things on Math1030 and the extra homework problems, so you can check out the answer there. Okay, last question on the exam. This one is a bit of a logic puzzle. You got to find the mistake. Leonard is working on the limit of the sequence negative 0.5 to the power n. And here's his logical reasoning. An is bigger than 0 when n is even, and an is less than 0 when n is odd. Since the sequence alternates between even and odd numbers, positive and negative numbers, right? It goes positive, negative as you go through the even and odd numbers. It cannot get closer and closer to any individual number. So positive, negative, you're always floating around. They're saying, therefore, it's not getting close to anything. Therefore, by the definition of a limit, the limit does not exist. So since we're not getting close to any individual number, the limit does not exist. There's a mistake somewhere. Put an X next to the line that has a mistake. So first of all, you should, in your notes, be able to find the limit of the sequence. The limit of this sequence is 0. The limit is 0. That should be in your notes somewhere. We know that if you have power, if the power is less than 1 in absolute value, then the limit will be 0. Okay, so the limit is 0. Why is the limit 0? Well, it does alternate between negative, positive, but the negative, positives are kind of cycling in towards 0. So this is like a door that is swinging, and it swings open, and then it swings closed, and it goes like bing, and goes towards 0. So the limit is 0. Let's see where Leonard went wrong. Now that we sort of have a picture of what's going on, it's going, the sequence goes from here to here to here to here. It's going negative, positive, but it kind of swarms in towards 0. So let's go through the argument one more time and see which statements are right and which ones are wrong. an is positive when n is even, and an is negative when n is odd. This one is perfectly true. It is going positive, negative, because of this negative sign to the power n. Since the sequence alternates between positive and negative numbers, it cannot get closer and closer to any individual number. Well, it is getting closer and closer to 0. And sort of 0 is in between the positive and negative numbers. So because 0 is on the border between all the positive numbers and all the negative numbers, this statement is false. This one is the wrong one. It can get closer and closer to 0 because 0 is close to both positive and negative numbers. What is written here is saying it can't get close to any positive number and it can't get close to any negative number, but it can get close to 0. So number 2 is wrong. Number 3, assuming number 2 is correct, number 3 would be correct. If it didn't get close to any individual number, then the limit would not exist. So number 3 is a correct statement. Therefore, the limit does not exist. Because it doesn't get close to any numbers, the limit does not exist. That is a true statement. It's just that number 2 was false. What you're building off of is false. So the X is definitely in statement number 2. Give a 1 or 2 sentence explanation. I think you could say the numbers alternate negative, positive, but get closer and closer to 0. 0 is close to both positive and negative numbers. Both positive and negative numbers. So what Leonard said is false. It is alternating, but it's alternating and getting closer to 0. That is what's going on here. That's why number 2 is false. Of course, any reasonable explanation that captures that idea would be full marks here. So that's something that I wrote. That would be correct. Okay, and I will stop there for the answers to the midterm.